Hello everyone, welcome back to Batch of Excellence. This is Sagar Darvi, your chemistry teacher, and today we are going to discuss a new chapter and the last chapter of organic chemistry, that is chemistry in everyday life. Well, dear students, before we actually start with this chapter, let me just brief you what this chapter is all about and why it is important for us to learn. Firstly, this chapter, chemistry in everyday life, rather than part of your syllabus, I would say it is a very important part of your life, because so many things that we come across in our daily life, today we are going to learn about all that. For example, see, when some disturbances in our biological process takes place, then we experience some general illness, some mild or moderate illnesses. For example, we experience minor pain, we experience headache, we experience cold, fever, all those kind of general illnesses. So when we are experiencing any of this kind of illnesses, not always we approach the doctor. Sometimes we take medicine ourselves. So we need to know that which particular medicine has to be taken when we are experiencing any of this kind of disturbances in our biological processes. For example, it is very common that when we are experiencing some minor pain in our body, we tend to take paracetamol. So we know that what is the function of paracetamol, right everyone? So in this chapter, we'll be discussing about all those classification of wide varieties of drugs, and particular drugs, if we are known by its name, then it belongs to which particular category and what is going to be its pharmacological effect. All this basic information we'll be learning in this chapter. Other than that, in our daily life, we come across soaps and the detergents. So all those types of soaps and the detergents, chemically, what are those kind of compounds? We are going to learn that today. So everyone, more or less, this chapter is going to be an informative chapter. You won't find we writing mechanism like we often do it for other parts of organic chemistry. So yes, it is going to be an informative chapter. But let me also tell you that if you see all previous year question, you will find at least one odd question coming up on alternate years. So that's why this is important as well. Well, now, as far as examination point of view is concerned, I would say the information is going to be quite easy. The only thing will be, if you're talking about a particular class of a drug, then we will have to remember many names of that particular category of a drug. So the task for you guys is going to be of remembering the names of a different chemical substances or drugs, what you can call. All right, everyone. So yes, you will find at times things are getting more informative, but we have no option. It's just that we'll have to make sure that we are practicing enough to remember the names of medicines. So guys, let's get started with chemistry in everyday life. Let me just brief you first what precisely we are going to learn today. So first we'll get introduced to the drugs and the classification of drugs. Then we'll talk about how drugs exactly interact with some macromolecular targets, which we call it as drug target. So we'll be learning interaction between the target molecules and drugs. And then, like I said, we will be learning different classes of drugs and examples of each one of that, which will include what are antacids, what are antihistamines. We'll be talking about tranquilizers. Well, tranquilizers are those drugs which we basically eat or we take it for any kind of disease or disturbances such as stress, anxiety, or any other those kind of mental illnesses. We'll be also learning about analgesic. Of course, painkillers belong to this category. Then we'll be talking about antimicrobial. Antimicrobials, basically, they are nothing but antibiotic, antiseptic, and disinfectant. So all those three categories will be coming under antimicrobials. And then eventually birth control pills is what you call it as antifertility drugs. So guys, these are the different classes of drugs that will be coming across. And like I said, the only task for you guys would be to remember the examples of these different classes. Once this is done, we'll be then talking about artificial sweetening agents. So these are basically chemical substances that we use in our food. Followed by, we'll be talking about cleansing agent, that is soap, and synthetic detergents. So guys, let us get started with the first, that is what are drugs. Well, let's take example of what we come across in our daily life. Look, suppose if you are experiencing some pain in some part of our body, or even if you are experiencing, let's say, headache. So we take a tablet such as crocin, a very commonly used tablet, right? If you have ever seen that tablet, then you will see that on that tablet, it is, anyways, one tablet is going to be how much? Like probably 1 or 2 grams. Yes. But if you read what is written on the tablet, you will find it is written 100 mg, 50 mg, sometimes as low as 20 mg also. So that mg that we see, that is basically an API. API is active pharmaceutical ingredients. So if your tablet is altogether, let's say, of 1 or 2 gram, but the active medicine which is going to make an impact or whatever illness you are experiencing is going to be just probably 50 milligrams. Rest of the thing which is present to make the entire weight of a tablet as 1 or 2 gram is basically other substances such as fillers or binders or some other food additives, etc., etc. So the actual medicine which makes an impact or which treats the disease or illness is just about, let's say, 50 mg. So if you see the drugs which we eat, we always take it in a very, very low concentration. You will find these drugs or the chemical substances are the substances of low molecular masses. Now, when you eat those substances, these chemical substances interact with some of the macromolecules in our body, such as carbohydrates, proteins, lipids, etc. Now, when these chemical substances, which are of low molecular masses, interact with the target molecules, the macromolecule which I said, this creates some therapeutic response. If the response created or if the response given by the interaction between chemical substance and the macromolecule is therapeutic and comforting to us, then those chemical substances, we call it as drugs. So dear student, what are drugs? Drugs are basically chemical substances of low molecular mass which interacts with macromolecular targets and produces some biological response. If that biological response is therapeutic, comforting, relieving, then we say those chemical substances are drugs. Now, like I said, we generally eat drugs in a very low concentration. The same drugs, if taken in a very high concentration, then those chemical substances could be potentially poisonous also. Right, everyone? And you must have seen that these medicines we use for several processes. Sometimes such chemical substances are used to diagnose, to find out what exactly is happening in the body. Sometimes they are used to prevent the spread of a disease or aggravation of that illness. And sometimes we use to cure the disease that person is going through. So basically these chemical substances or the drugs which we take in a lower concentration are used for diagnosis purpose. They are used for preventing the disease or illness, or sometimes they are used to cure the disease as well. So guys, that is all about what you call it as a chemical substances. We call them as drugs. So here's the definition that we saw just now. Now, how do we exactly classify drugs? There are 4 ways by which we classify the drugs. First classification is on the basis of pharmacological effect. Alright, now what does pharmacological effect means? Well guys, look, let's say if I name some of the medicines such as crocin or paracetamol or aspirin or Myospars, these all are very common names that we have come across in our daily life. But if you see, why do we eat or when do we eat them, you will find one common cause or common reason behind it. We eat this kind of medicine which I named just now when we are experiencing some pain. So they all are collectively called as painkillers. So a particular types of a drug which are used to treat against the pain, we call them as collectively painkillers or we call them as analgesics. So a classification of a drug in general on the basis of the effect of that medicine is what you call it as the pharmacological effect. The classification on the basis of pharmacological effect. So this classification basically helps us to find out the category of that particular medicine, like painkillers, like antacids or antihistamine or anti-fertility, so on and so forth. Alright everyone. Second classification of drug is on the basis of drug action. Well, this kind of drugs or this classification of drugs talks about a particular medicine is acting upon a particular biological process. For example, let's say in our body, because of something, we are experiencing inflammation, which is eventually going to cause a pain in some part of our body. So we'll have to first figure out what biological process is causing that particular inflammation in the body that is eventually going to cause pain in our body. So we will eat a medicine which is going to act upon that particular biological process which is causing the inflammation. So to treat that biological process, we will use a particular medicine or a particular drug. So this way, when we classify the drugs on the basis of treatment against a particular biological process, then we put those drugs in the category of classification on the basis of drugs action. So it's very specific with respect to the action of a drug against particular biological process. Third classification, classification on the basis of chemical structure. Well, like I said, if we call any particular drugs based on its pharmacological effects, so let's say we talked about painkillers or we talked about antihistamines or any of those category of a drug, if you see all those drugs and find out its structural features, you will find all those drugs which belongs to a particular category will have some structural similarities in it, and hence their pharmacological effects are also identical, or you can say similar. So when you classify a particular drugs on the basis of the structural similarity in it, all those drugs will be said to be classified on the basis of their chemical structures. And finally, on the basis of molecular targets. Look, few minutes back when we defined drugs, we said drugs are chemical substances which interact with some molecular targets. Molecular targets such as proteins or carbohydrates or lipids, etc. Now, a particular drug has a tendency to combine with a particular type of molecular target. Like let's say if we are using or we are eating some drug, then the drug will have a tendency to interact with enzymes specifically, not with carbohydrates or lipids. So in such case, that medicine or the drug will be said to be belonging to a category that it is going to combine with which molecular target. So when we classify drugs like that, we say those drugs belong to category on the basis of, or they are classified as drug on the basis of molecular targets. So depending upon a particular medicine is specific to attach with which macromolecular target, we classify it as the classification on the basis of molecular targets. So guys, these are 4 ways basically by which we classify the drugs. Now, since we have been talking a lot about medicines, of course, it excites us to know how exactly these medicines helps us to cure a particular disease or particular disturbances that is happening in our biological process. But guys, before you actually enter into know how exactly these drugs affects the biological process, we need to first understand how in general biological processes takes place themselves, and then how drugs are used to repair those processes. Hence, it is important for us to first understand that how exactly a particular biological processes takes place. So in order to understand drug target interaction, like I said, drug target interaction, target are those macromolecules. Targets are those macromolecules which basically are responsible for some of the biological processes. For example, if I talk about enzyme, so enzymes are basically proteins which performs a function of a biological catalyst in the body. So enzyme is one of the macromolecular target, and that enzyme is nothing but protein molecule which performs the role of biological catalyst. So enzyme is one of the target or a macromolecule. Similar to that, there is another target which you call it as receptor. So receptors are those proteins which are basically important for the body's communication process. So the communication that happens in our body is basically performed by the macromolecules, which we call it as receptor. Now when I talk about communication, what does that mean? See, the signal in the body from one neuron to other neuron, or maybe from neuron to muscle, is carried by some of the part of body, which is what you call it as receptor. For example, let's say while playing we fell down and we got some wound on our leg, okay, in our leg. So that wound is now slowly started causing inflammation, and then that inflammation is going to cause pain in that part of our body. But that pain which is caused in the body, or the inflammation which is caused in the body, is to be communicated through some chemical substances to our brain. So that communication process right from the wound and the signaling to our brain is carried out. That process is basically carried out by the macromolecule, is what you call it as receptor. So basically today here in our chapter, as far as our syllabus is concerned, we will be discussing about two important macromolecules or molecular targets. One is enzyme and receptor, and then we will see how drugs interact with this enzyme and with receptor. But before we learn the interaction, we'll have to first understand how enzymes and receptor function themselves, and then we'll talk about how drugs interact with them. So let us first talk about enzyme as a molecular target. So like we said, enzymes are basically a protein molecules which are responsible for the catalytic activity for a particular biological processes. All right. So how exactly this enzyme functions? Let us see that first, everyone. Okay. So let's say this is a protein molecule which you call it as enzyme. You see here in that enzyme there is a particular site which we are calling it as an active site, or there is a cavity which you are calling it as active site. So what this enzyme does is, this enzyme provides this active site for some substrate to come and get accommodated in this particular cavity. Now accommodation of that particular substrate in this active site takes place via several interactions. So the interaction between the substrate and the active site could be via ionic bonding, or could be van der Waals forces, hydrogen bonding, so on and so forth. So what this enzyme does, it provides active site for the substrate to get accommodated in this particular active site. Once it gets accommodated, you can see the substrate is being accommodated in the active site like here, and the interaction that is taking place between the substrate and this part of enzyme is via ionic bond or weak van der Waals forces, or could be hydrogen bond. Once it get deposited in this active site, now the second function this enzyme does, this enzyme allow this substrate to react with external reagent. Let me show you that diagrammatically. So you see enzyme has provided active site. This active site basically will allow substrate to get deposited here, and then this substrate will be brought in contact with some external reagent. So this, after getting accommodated, will interact with some reagent and will produce some biological response. Now let us take one example. Again, whatever example I'll be telling you, this is just for the sake of understanding the concept. Biologically, it need not be absolutely correct all the time. All right. So let's say if I'm talking about we went for a party to a friend's place the other night, okay, and we ate some food which was probably not good, or it was a spoiled food. So because you ate a spoiled food, it started creating some infection in your body, which you call it as in general food infection. All right. So the next morning you started experiencing stomach ache, and slowly you started getting feeling of vomiting, and you realize that the food infection has occurred in your body. So how is this process related to the enzyme and the substrate interaction? Is, let's say the food infection that is causing or that is taking place in your biological system is slowly enhancing, is slowly increasing. And how is that increasing by time? Is because this enzyme is allowing some substrate molecule to get deposited, and once they get deposited, they are allowing some external reagent to react with it, and the reaction rate have been getting increased. So whatever reaction is taking place, its rate have been increased because these enzymes are acting like a biological catalyst. So the food poisoning that we are experiencing is getting aggravated by time because it is being catalyzed by some enzyme present in our system. Now what we do, once we start experiencing this, we go to the doctor, and doctor gives us some medicine, and that medicine, probably after eating, maybe in a day's time or maybe in few hours, we start feeling better. So what this medicine is doing is what we have to understand: drug target interaction. So now see, now we went to a doctor and doctor gave us some medicine. Let's say this is the medicine or a drug. Now if you see, the shape and the size of drug is exactly similar to that of substrate. So when you will eat the medicine, what this medicine will do, this medicine or the drug will compete with the substrate which was getting deposited in the cavity of enzyme. So this drug itself will get deposited or itself will get accommodated in that active site and will not allow substrate to get accommodated in this active site. So what this drug has done is, this drug has literally competed with the substrate and itself got accommodated in the active site. Now once drug get accommodated in this active site, of course there is no way now substrate can come and get accommodated. So the interaction between the substrate and enzyme have been inhibited. If substrate will no more get accommodated in the enzyme, it cannot further react with the reagent, and hence no further reaction will take place. So the food poisoning that we were experiencing, that reaction rate or that catalysis of the reaction have been now prevented. And now if you eat sufficient concentration of drug, this drug will not let those substrate to get accommodated in the enzyme, and hence slowly it will stop that reaction which was causing a food poison in a biological system. So such drugs which directly compete with the substrate and inhibit the reaction, we call it as competitive inhibitors. What do we call it? Competitive inhibitors. So one of the type of drug which directly compete with the substrate and inhibit the reaction or catalyze reaction is what we call it as competitive inhibitor. So this is one of the type of interaction of a drug with the enzyme. Now see, not always the drug directly compete with the substrate and get accommodated in the active site. Sometimes those drugs get accommodated in some other part of enzyme. You see here, let's say there is one more part in the enzyme which we are calling it as allosteric site. This is allosteric site, let's say. So now we ate some drug or a medicine. That medicine got accommodated in this allosteric site, not at the active site. But when this medicine gets attached or gets accommodated in the allosteric site, it changes the shape of active site. You see, the shape of active site has changed because now drug has been accommodated in the allosteric site. If the shape of active site has changed, then even if substrate is available, this substrate will not be able to fit into this active site because the shape of active site has changed altogether. So this cannot fit in here, just like lock and key. As a result of which, there is no deposition of substrate anymore taking place on the cavity or on the active site of enzyme. So no further catalytic reaction can take place. That's how the catalytic reaction have been inhibited. But in this inhibition, drug is not directly competing with the substrate. So such kind of drugs or the medicine, we call it as non-competitive inhibitors. So guys, those medicines which prevents the catalytic action of enzymes are of two types: competitive inhibitors and non-competitive inhibitors. So this was first interaction of medicines or the drugs with the enzyme, which are nothing but macromolecule. We call them as molecular targets. Just like enzyme, like we said, the second macromolecule which we are going to learn, and we are going to learn its interaction with the drug, is a receptor. Receptor are again those protein molecules which are essential for body's communication process. Like I give you an example. If at some part of your body you have got hurt, then you start experiencing pain. But who tells you that you are experiencing pain? How your brain come to know that you are experiencing pain is through the receptor and its interaction with the chemical substances. So guys, let's try and understand first the functioning of receptor. Okay, so now what we are talking, receptor as a drug target. Let us read this basic information first to understand. You are absolutely not required to remember this diagram, but for understanding how the receptor communicate with the body, it is important for us to see at least the required part of it. So what is this? This is basically animal cell, and this is the magnified image of a cell membrane. Let's come here. Receptors are protein that are crucial for body's communication process. Majority of these are embedded in the cell membranes. Receptor proteins, you can see. Now, this is basically your internal cell. So, receptor proteins are embedded in the cell membrane in such a way that their small parts possessing active site project out of the cell membrane, project out of the surface of cell membrane. So guys, in this animal cell, if this is the diagrammatic representation of cell membrane, this shape that you see here, this one, is basically that protein which we're calling it as receptor. So you'll see receptor is actually embedded in the cell membrane, but some part, this part we are talking about, this part is projecting outside the cell membrane, you see. So this part is projecting outside the cell membrane, and this is what we call it as active site. Okay. Now what happens basically is in our body there are some chemical substances which are secreted by the body itself, and those chemical substances are responsible for communicating between two neurons or from neuron to muscle. Those chemical substances which communicates in our body or sends a signal to our brain is what you call it as chemical messenger. But how does this chemical messenger actually passes the signal to our body? To understand that, let's see the next diagrammatic representation. So this is the active site. This active site, or you can also call it as binding site. This is what you call it as chemical messenger. The chemical substances which is responsible for transferring the message is what you call it as chemical messenger. So see what has happened. A chemical messenger or a chemical substance which is secreted in the body itself get attached to the active site of receptor. When itself get attached to the active site of receptor, in order to accommodate this chemical messenger, this cell changes its shape. You see that? Not cell, this receptor is changing its shape. So in order to accommodate the chemical messenger, the receptor protein is changing its shape. So change in the shape of the receptor protein is an indication that the chemical message has binded to the active site. So let's say this chemical messenger have got attached to the active site of the receptor protein and it has changed its shape. So the change in the shape itself is the signal given to the cell that some chemical messenger has conveyed some message to the body. So a message is conveyed to the cell without actually interacting with the cell. See, the chemical messenger has not interacted with the cell. It has just interacted with the receptor protein. But change in the shape of receptor protein itself is an indication that some message has been conveyed. So you will find there are several such receptor protein present in our body, and every particular chemical messenger has a specificity to attach to particular receptor. That's why the different kind of signals which are given to our brain are conveyed by the different type of chemical messenger which attaches to the different or the specific type of receptor protein. So that's how the communication or the signals are sent to our brain by the interaction between chemical messenger and the receptor protein, and this is basically and this is basically taking place because of change in the shape of receptor protein. All right, now we'll have to understand from where does drugs are coming into picture, or how medicines are going to interact with this receptor protein. Well, we'll be taking two examples. Okay. Again, whatever example I'm giving you, this example probably will have to consider just for the sake of understanding of concept. Biologically, it need not be exactly correct one. All right. Well, guys, we all are aware that when we experience or when we feel good for ourselves, there is some hormonal play that is taking place in our body. Those hormones basically make us feel good, or they give us feeling of well-being, or those are the ones which are responsible for keeping our good mood intact, right? Now let's say because of some mishappening that is happening in our life, probably that particular person is now no more feeling, well-being. He started experiencing some stress, probably he is undergoing some kind of depression. So he go to the doctor, and doctor prescribes some medicine, probably tranquilizer, or probably some antidepressant drugs, or those kind of medicine, or stress related medicine. He eats those medicine and he starts feeling better. Now what exactly is happening here? Look, when our body started experiencing not being well, it is probably because, hold on everyone, yeah, guys, hold on. All right, so what I said, there are some hormones basically which are secreted in the body, and those are the ones which are responsible for making us feel good, right? Now what happens, those hormones are the chemical substances gets deposited at the active site of receptor, and then the shape of receptor has been changed, and the change in the shape is signaling your body that you're feeling good, so you're in a good mood, right? Now let's say because of something like I said, you started feeling, experiencing the depression. So doctor gave us some medicine. Now the medicine that is being taken here, everyone, when you started experiencing depression, which means those chemical messenger or the chemical substances which were getting secreted in the body, those concentration or the secretion amount have been decreased in the body. Because of decrease in the concentration of those happy hormones have been decreased, your body is no more experiencing or no more having that feeling of well-being. So the whole reason why you're not experiencing happy is basically because those chemical substances which were responsible for signaling your body that you're experiencing or you're feeling good have been decreased. Now the medicine that we are eating, or medicine which are prescribed by the doctor, are those medicine which are going to copy or mimic the same chemical messenger which were responsible for making you feel good. So now those medicine themselves will get attached to the active site of this receptor protein, and it will exactly mimic the same role as it was done by the original chemical messenger. So you again start feeling good. So this kind of medicines or the drugs which basically copies the function of those chemical messengers, we call them as agonist. Now let's take another type of, or take another example which explain the type of drug which we call it as antagonist. What are agonists? Agonists are basically those medicines which are going to mimic or copy the function of some chemical messengers. Now let's understand antagonist. Well, now like I said, because of some injury, if person start experiencing unbearable pain, then let's say if person has met with some accident and he has got some injury. Now that injury can only be treated by operation, let's say. So he goes to the doctor. Now the first thing doctor do is, if the pain that person is experiencing is unbearable, doctor first give anesthesia to that part of a body which is to be operated, right? The moment doctor gives anesthesia, that person no more experiences that pain. Again, the example I'm giving you just for the sake of understanding the concept. It need not be biologically absolutely correct. Okay. Now, the moment doctor gives anesthesia, that person no more experience that pain. So let's say the pain that person was earlier experiencing was because of some chemical messenger. So chemical messengers, when was getting deposited or getting binded to the receptor protein, the shape of the receptor protein was changing, and that change in the shape was signaling to the body that some inflammation is taking place in the body, which is responsible for that unbearable pain. Now doctor gave us some medicine. Now what that medicine is going to do, that medicine will not allow those chemical messenger to bind themselves to the receptor, because those chemical messenger, if get attached to this receptor protein, they are going to signal to the body about the pain or the inflammation. So the medicine which was given by the doctor, let's say anesthesia. So let's say anesthesia is external chemical messenger that we have injected in the body. So that anesthesia will now compete with the chemical messenger and itself will get attached to this binding site. But because the anesthesia which is given is not communicating a message of inflammation in the body, our body no more experiences that inflammation. So now what anesthesia has done is, anesthesia has prevented or inhibited the activity of chemical messenger, because of which we are not going to experience that unbearable pain. So such chemical substances which inhibits the activity of chemical messenger are what you call it as antagonist. So there are two types of medicines that we studied here. One, agonist, which mimic or copy the action of chemical messenger, and second is antagonist, which basically opposes or inhibits the activity of chemical messenger. We call them as antagonists. So dear students, these are the two terms. First we studied agonist. What are agonists? Agonists are those types of drugs or medicines that mimic or copies the natural messenger by switching on the receptor. These are called as agonists. The example which I gave you, when you are undergoing depression, which means there is a decrease in the concentration level of that chemical substance which was making you feel well-being of yourself or happy. So basically this kind of medicine, agonists, are useful when there is a lack of a natural chemical messengers. And what is antagonist? Antagonists are those drugs that bind to the receptor site and inhibits the natural function of chemical messenger. Like anesthesia. Anesthesia itself got attached to the receptor and inhibited the interaction between the natural chemical messenger and receptor. So guys, when we studied interaction of a drug with the target, the first target we studied was enzyme. And with enzyme, there are two types of drugs which we studied: competitive inhibitors and non-competitive inhibitors. Competitive inhibitors directly compete with the substrate and themselves get attached to the active site. Non-competitive inhibitor attaches itself to the allosteric site and changes the shape of active site such that that enzyme can no more accommodate the substrate and is no more further interaction with reagent can take place. Whereas when you talk about drug and receptor interaction, there are two types of drugs which can interact with the receptor and produce certain signals. Those drugs or the medicines are agonist and antagonist. Agonists are the ones which copies or mimics the activity or the function of natural messenger. Antagonists are the one which inhibits the function of natural messenger. So dear students, what we have studied so far? Well, we studied three things here. First, we got introduced to a term called as drugs or the medicines. Second, we saw how exactly are we supposed to classify the drugs or how exactly we classify the drugs. And the third one, we studied the drug and target interaction. So we studied interaction of drug with enzyme and interaction of drugs with receptor protein. Now we are entering into the most important part of chapter, that is different classes of drugs and its therapeutic actions. So guys, just hold on. Okay, everyone. So this is what I was talking about. Why we have to learn this chapter is because there are so many things which we come across in our daily life and we need to have a knowledge of that. So the first important type of drug or the class of drug that we are learning is antacids. Alright guys, we all are aware that when we experience that excess of acidity, we eat Eno or we eat a tablet called Gelisil, right? Or Omaze is another tablet that we eat before eating the food. Now these all medicines are basically what? They are the one which neutralizes the excess of acidity that we have in our stomach. So those medicines which are used to act against the excess of acid is what you call it as antacids. So if you talk about the historical development of antacids, in old days we commonly used to eat antacids such as bicarbonates or metal hydroxide such as MgOH twice or AlOH thrice, that is aluminum hydroxide, magnesium hydroxide and bicarbonates. Out of which if we talk about the bicarbonates, bicarbonates are not the best of antacids which are considered. Why? Because these bicarbonates are found to be soluble in water, and because they're water soluble, let's say if person is experiencing an acidity, so a person ate that bicarbonates in excess, so whatever acidity that person was experiencing, let's say that acidity got neutralized by the base, that is bicarbonate eaten by that person, but because the bicarbonate that person has consumed is in excess, the excess amount of bicarbonate which is present in the stomach, that will cause secretion of more acid to neutralize this bicarbonate. I repeat, if person is experiencing an acidity and let's say that person has eaten the bicarbonate as an antacid, so as much of acidity that person is experiencing, let's say the whole acidity got neutralized by the bicarbonate, but the bicarbonate which that person has consumed is in excess. So the excess amount of bicarbonate which is consumed will now make body to secrete even more acid to neutralize the excess of base. So in this process, what is happening? There is excess of acid which is getting secreted by the body because bicarbonate is water soluble. Hence, it was important that you eat precise amount of bicarbonate. By mistake, if you eat excess of bicarbonate, body is going to secrete more and more acid. Hence, it was not the preferred antacid. So we started eating hydroxides, metal hydroxides such as aluminum hydroxide or magnesium hydroxide. Now these metal hydroxides being water insoluble, it does not cause our body secrete more and more acids. Hence those are the preferred one. So preferred antacids are metal hydroxides, but earlier we also used to eat or consume the bicarbonates. However, let me tell you, in our body there exists a chemical substance called as histamine. What that histamine does is, this histamine secretes a substance called as pepsin and hydrochloric acid, which causes inflammation or which causes excess of acidity. So to neutralize this acidity, some other antacids or chemical substances were discovered, which were basically cimetidine, also known as tagamet. So cimetidine was one of the most commonly used antacid which was used in earlier days until the next chemical substance which was derived called as ranitidine, also known as Zantac. So guys, you will have to remember the names of antacid. First of all, bicarbonate and metal hydroxide, AlOH thrice, MgOH twice. Other than that, two more antacids that you will have to remember, cimetidine and ranitidine. Next category of a drug, we call it as antihistamine. Well, just now I talked about histamine being responsible for creating acidity by secreting pepsin and hydrochloric acid. Other than that, histamines also are the ones which are responsible for allergic interaction. So nasal congestion or running eyes, watery eyes, running nose, all these are the allergic responses which are caused due to histamine as a chemical substance. So those medicines or the drugs which are used to inhibit the action of this histamine, which causes the allergic responses in our body, those chemical substances are called as antihistamine. As the name suggests, those medicines which will function against the histamine action are called as antihistamine. So which antihistamine we'll have to learn? First one is brompheniramine, which is also known as Dimetapp or Dimetapp. See, we are taking all the possible names here because in exam the question can be asked with respect to any of these names. So remember, the first antihistamine is brompheniramine, also known as Dimetapp or Dimetapp, and second one is terfenadine, also known as Sildane. So antacids, which antacids we came across so far? First one, bicarbonate, then metal hydroxide, then other than that ranitidine and cimetidine. Antihistamine are the one which inhibits the function of histamine. Histamine is the one which causes allergic reaction in the body. So which are the example of antihistamine? Brompheniramine, also known as Dimetapp or Dimetapp, and then terfenadine, also known as Sildane. Guys, I would highly recommend you all that you take a particular category and write down the names of drugs related to that category at least 4 to 5 times so that you will be able to remember it, because you will find maximum questions will be related to the names of drugs only. Well, after this, the next category of a drug is what you call it as neurologically active drugs. So there are two types of drugs, tranquilizers and analgesics. First, let us get introduced to what exactly a tranquilizer. Well, what is the meaning of tranquil? Tranquil is the term which is related to calmness or peace of mind. So any medicine which is used to bring that calmness is what you call it as tranquilizer. So tranquilizer is that category of a drug which is basically used to treat against the stress or any kind of mental illnesses. So hence we say tranquilizers and analgesics are neurologically active drugs. These affect the message transfer mechanism from nerve to receptor, and tranquilizers are the class of chemical compounds which are used to treat or which are used for the treatment of stress or mild or severe type of mental diseases. Alright, so here are some example of tranquilizers which we'll have to learn. Iproniazide, phenelzine, which is also known as by the name Nardil, meflobromate, chlordiazepoxide and equanil, and along with this you can also add to the list called equanil and Valium. So guys, these all are the example which belongs to the category of tranquilizers. Again, tranquilizers are those medicines which are used to treat against the mental illnesses or any mental disease or stress, or in fact in the sleeping pills we use some of the chemical substance which also belongs to the category of tranquilizers only. And the example that we'll have to remember: iproniazide, phenelzine, meflobromate, chlordiazepoxide, equanil and Valium. Other than this, there are some more which are basically considered to be a derivative of barbituric acid. So since these all are the derivative of barbituric acid, we call them as barbiturates, or you also call them as hypnotic drugs. So to remember this, simply remember the word vanillas. Vanillas, V stand for veronal, A stand for amityl, N for nembutyl, L for luminal and S for seconal. So I simply remember this as vanillas. VANLS, veronal, amityl, nembutyl, luminal and seconal. Other than this, there are two more called Valium and serotonin. Well, so iproniazide, phenelzine, meflobromate, chlordiazepoxide, equanil, Valium and serotonin, you remember them also together, and then simply add vanillas: veronal, amityl, nembutyl, luminal and seconal. Alright, so this category of a drug is what you call it as tranquilizers. Well, other than tranquilizer, the next category that we said is basically analgesic. Analgesic, in simple term, you can also call it as painkillers. Alright, now this analgesic we further classify into two categories, and those two categories are narcotics and non-narcotics. narcotic and non-narcotics. Well, there is a term called as narcosis. Narcosis is, you can say, a feeling of being in a deep sleep is what you call it as narcosis. So you will see some kind of painkillers that we eat makes us feel like we are in a deep sleep, and hence those kind of painkillers could be addictive as well. So when you say there are two types of painkillers or analgesic, which are called as narcotic analgesic and non-narcotic analgesic. So narcotic analgesic, like I said, the term narcosis meaning feeling of being in deep sleep. So those analgesic or painkiller which makes us feel that we are in a deep sleep, if consumed in excess amount or on a regular basis, those could be addictive as well. Hence narcotic analgesics are called as addictive painkillers, and the example of those are morphine, heroin and codeine. Morphine, heroin and codeine. Well guys, these are high potency analgesics or painkiller you can call, and hence these are used for treating the kind of you can say pain a person experiences when they have undergone surgery. So when a particular person have undergone surgery, after surgery the pain that person experiences is enormous. So to subside those kind of pain, the medicines which are given are of this category called as narcotic analgesic. Or a person which is let's say if if a particular person has treated for the cancer, let's say, so after cancer also the body when experiences enormous pain, then to subside those kind of pain, again we give this kind of medicine. So whenever any pain which is unbearable, then to treat those kind of pain we need high potency painkillers which are called as narcotic analgesics. Whereas aspirin, paracetamol, crocin are very general painkillers that we use in our daily life as well, right? So if we are experiencing, let's say, headache, so what we do? We eat aspirin, we eat crocin. Or if we are experiencing some minor muscular pain, what do? We eat myospas or we eat paracetamol. So these kind of medicines are used to treat minor, or you can say a moderate pain, and they are non-addictive. So narcotic analgesics are addictive, which are used to treat against unbearable pains such as post-operative pains, or a person who has undergone treatment of cancer, they also experience those kind of pain, so we give them this kind of medicine. Whereas for the general pain, or to stop or kill that general pain, we basically give them a substances called or medicine called aspirin and paracetamol. So in general, analgesics are painkillers which abolishes the pain without any side reaction. Without any side reaction as in without causing any other disturbances to the nervous system. Guys, the categories of a drug which we have studied so far, let me just revise once again. We first started with antacids. So antacids basically are used to neutralize the excess of acidity. For example which we saw, I repeat again, we discuss about bicarbonates, metal hydroxide, that is MgOH twice, AlOH twice, and other than that we also studied ranitidine and cimetidine. After that we came across medicines called as antihistamine. Examples of antihistamine we came across were brompheniramine, right everyone? And then we studied another category of medicines or a drug which is basically analgesics, before which we studied tranquilizers. These all are the example which come under category of tranquilizer. Then under the tranquilizer we also studied the subtype that is called hypnotic, or also called as barbiturates. You'll have to remember all these examples. Followed by neurologically active drugs. The second category is analgesic. After tranquilizer we are learning analgesic, which are of two types, narcotic and non-narcotic analgesics. Well guys, like I said right in the beginning, this is an informative chapter, so you'll have to remember many names of the drugs. The next category of a drug that we are learning is called as antimicrobial agents? Well, since we have recently come out of coronavirus, we know that how these pathogens such as viruses, then bacteria can affect our body adversely. Hence, we need some medicines to treat them, either to stop the growth of such microbes or to kill such kind of microbes. We need some medicines. Those all medicines which are used to prevent the growth or kill those kind of microorganisms is what you call it as antimicrobial. So antimicrobial are further of three categories. One is antibiotic, second is antiseptic, and third one is antiseptic. The first one is antibiotic, then antiseptic, and third one is disinfectant. Now, how does these three differs from each other? Well, let's first talk about the antibiotic. Just to give you an example, let's say we are experiencing a throat infection. So we go to the doctor and doctor prescribes us medicine. One of the common medicine doctor prescribes is erythromycin or azithromycin, right? So we have to eat that tablets. So after eating, that active pharmaceutical ingredients act upon the infection or the bacteria which are causing that infection, and then we start feeling better. So basically antibiotics are the medicine which we eat. Again, a particular type of antibiotic that we eat need not be applicable for all the infections that we are experiencing. So there is a type of antibiotic that we eat. So let's understand what are the different types of antibiotics. One type of antibiotics are the one which basically stops the growth of microorganism, whereas second types of antibiotics are the one which kills the microorganism. So those antibiotic which stops the growth of microorganism, we call them as bacteriostatic, which stops the growth of bacteria. And the second type which kills the bacteria is called as bactericidal. Bactericidal means those are the medicine which are going to kill the bacteria. This is the first classification. Then the second classification of antibiotic is based on which particular type of bacteria that particular medicine can treat. So we classify them as broad spectrum antibiotic and narrow spectrum antibiotic. Broad spectrum antibiotics are the one which are used to treat against gram positive as well as gram negative bacteria, and the narrow spectrum antibiotics are the one which are used to treat against either gram positive or gram negative bacteria. So guys, antibiotic can be classified in two categories. Number one, bacteriostatic, bactericidal. Number two, broad spectrum antibiotic, narrow spectrum antibiotic, and there are some specific spectrum antibiotic as well, but we need not look into it as of now. So yes, disease in the human beings and animals may be caused by varieties of microorganisms such as bacteria, virus, fungi, and other pathogens. An antimicrobial tends to destroy or prevent the growth or inhibit the pathogenic action of microbes, such as for treatment of bacteria we use antibacterial agents, to treat fungus we use antifungal agents, to treat virus we use antiviral agent, and for other parasites selectively. So based on that we classify this into three categories: antibiotic, antiseptic, and the third one is disinfector, are the three major categories of antimicrobial drugs. So first we are talking about antibiotic. Well, so antibiotics are the drugs which are used to treat against the infection, or which are used to treat the infections. Well guys, if you just go back to the history of this, in earlier days when the antibiotic was developed, the first antibiotic which was developed was salvarsan, which is basically a compound which was containing arsenic double bond. Well, so arsenic is a nitrogen family member. So that drug was found to be containing arsenic double bond. So you call it as arsphenamine. Whereas it is essential that the antibiotic that we are consuming should only stop or kill the bacteria which is present on the host cell, but it should not have any harmful effect on the host cell or host tissue. For example, if you are experiencing the throat infection and if you eat, let's say, erythromycin, that erythromycin should only kill the bacteria but should not have any harmful effect on the host tissue on which that bacteria have grown. So in the old days, medicine such as salvarsan, which was discovered by the scientists, was effective against the bacteria, but it was also harmful to the human. But of course, the harmfulness to the human was relatively to a lesser extent as compared to its impact on the bacteria, and that's why it was continued. However, as the research went on, we realized that there is another medicine called Prontosil, which is basically an azo dye which contain nitrogen double bond, which was found to be as effective as salvarsan and found to be having less effect or harmful effect on the living tissues, was relatively lesser. So we started using the next medicine, that is Prontosil. Other than that, there is another drug which is used as antibiotic called as sulfapyridine. Let me show you the structures of salvarsan and Prontosil. If you see here, this is salvarsan carrying arsenic double bond. You're not supposed to remember the structure, but at least you need to know the data. This was the first antibiotic, and similar to that, the other one which was discovered, which was even more effective with the lesser side effects, was Prontosil. Well, there is one common question that they generally ask. When you actually eat Prontosil, in our biological system, it basically breaks down and releases the substance that is called as sulfanilamide. So the actual chemical substances which acts like an antibiotic and functions against the bacteria is your sulfanilamide. So remember, when Prontosil is consumed, it basically releases the chemical substances which is actually effective against the bacteria, is called sulfanilamide. So those were some of the examples of antibiotic. However, after this, after salvarsan and Prontosil, so many synthetic antibiotics were developed. So let me show you the list of commonly used antibiotic and their categories. Guys, here is the list. Hold on for a while, everyone. Alright guys, here. So like we said, antibiotics we classify in two ways. First way of classifying is bactericidal, which has the ability to kill the bacteria, and bacteriostatic, which basically stops the growth of the bacteria. Some example of bactericidal are penicillin, aminoglycoside and ofloxacin, whereas bacteriostatic are erythromycin, tetracycline and chloramphenicol. I repeat, bactericidal are the one which kills the bacteria. Examples are penicillin, aminoglycosides and ofloxacin, whereas bacteriostatic are erythromycin, tetracycline and chloramphenicol. Second way of classifying these medicines or the antibiotic are broad spectrum antibiotic. Like I said, broad spectrum antibiotic are those antibiotic which functions against gram positive as well as gram negative bacteria, and the examples are ampicillin, amoxicillin, chloramphenicol, vancomycin and ofloxacin. Whereas narrow spectrum antibiotics are the one which works or which are effective against either gram positive or gram negative, and the example is penicillin G. That was all about antibiotic. Second category is what you call it as antiseptic. Well, as the name suggests, antiseptic meaning again it is going to function against the infection, poison, septic, right? However, these are the medicine which we apply externally on the living tissues. For example, if we have got some wound, we put Dettol over it. So what is Dettol? Dettol is antiseptic. So Dettol is that chemical substance which we apply externally on the living tissues. So the second type of antimicrobes is antiseptic, and then the third one is disinfectant. So antiseptics are the ones which are applied to the living tissues such as wounds and cuts. Examples, so many of these guys we have seen in our daily life as well. Furacin, soframycin is one of the very common antiseptic. Dettol, of course, will the structure of components of Dettol, it's mixture of chloroxylenol and terpineol. Then we have got bithionol. Well, bithionol or bithional you can call it. This is that chemical substance or antiseptic which we generally found in soaps. Then we have got iodine. Then there is tincture iodine and iodoform. These three are the antiseptic because of the antiseptic ability of iodine, and generally in the schools you see the antiseptic which is used is either of this. Then we have got boric acid. Boric acid is used as an antiseptic very commonly in the eye drops. So that's boric acid. Disinfectant is the third category after antiseptic. Disinfectant. Well guys, just to give you an example, in our house also we use disinfectant. For example, whenever we have to clean the floors or the surfaces of other tools such as table or whatever, so we use some cleaners, right? For example, we use, let's say, Lysol. Lysol is used as a floor cleaner. That is what we call it as disinfectant, which basically kills the microorganism. But understand the difference in antiseptic and disinfectant. Just to give an example, let's say one fine day we are out of Lysol. We don't have a Lysol at home, but we have got a Dettol. So what we do? We take a Dettol, we put it in a water, we make a solution and we clean the floor. Correct? The same Dettol is used for cleaning the wounds as well. So Dettol is used as an antiseptic and at times we also used as a disinfectant. Now see, imagine one fine day we don't have Dettol, but we have got Lysol. The same Lysol which we use for cleaning the floors. Tell me, one fine day if we have got some wound, will we be able to apply Lysol over there? We cannot. Why? Because Lysol, which is disinfectant, it is harmful to the living tissues, so we cannot use it. So the difference is antiseptic and disinfectant lies on, first of all, the concentration, and the second, whether or not it is harmful to the living tissues. So antiseptic are applied on the living tissues over the cuts or the wounds because they are not harmful to the living tissues, whereas disinfectant are harmful to the living tissues. So several times you will find some of the compounds in a lower concentration are used as antiseptic. In higher concentration they are used as disinfectant, such as phenol. 0.2% solution of phenol is antiseptic, whereas 1% solution of phenol is disinfectant. Similarly, chlorine in the concentration of 0.2 to 0.4 ppm in aqueous solution, and also sulfur dioxide in a very low concentration are used as disinfectant. So you can remember this example: phenol 1%, 0.2 to 0.4 ppm of a solution of chlorine, and sulfur dioxide in lower concentration will be acting as a disinfectant. So guys, antimicrobials, we studied three antimicrobial: antibiotic, antiseptic and disinfectant. Antibiotic which we consume, right, and internally they helps to get rid of those bacteria. Those antibiotic could be bacteriostatic or bactericidal, and they can also be classified as broad spectrum and narrow spectrum antibiotic. Whereas antiseptics are the one which we apply on the living tissues over cuts or the wounds that kills the growth of microorganism. Whereas disinfectants are the one which we generally use to clean the surfaces basically, and they also kills the growth of microorganism. So that was about the antimicrobes. So guys, what all category of medicine that we have come across? We studied antacid, we studied antihistamine, we studied tranquilizer, we studied analgesics, we talked about antimicrobes, that is antibiotic, antiseptic and disinfectant. You guys will have to write down all these examples several times to remember the names and their respective category. So you will see chlorosyleenol and terpineol are the constituents of Dettol. Dettol is a mixture of chlorosyleenol and terpineol. So these two are the structure. Probably these two structure you can remember. And here is the structure of bithionol, the one which I said commonly used in the soap, right? Well, the next category of a drug that we'll have to learn is anti-fertility drugs. Well, anti-fertility drugs, in simple words, they are nothing but the birth control pills, right? So to stop or prevent pregnancy, the medicines that a person eat is basically anti-fertility drugs. You will find these anti-fertility drugs are nothing but derivative of the hormones which are called as estrogen and progesterone. So estrogen and progesterone basically are the hormones, and the medicines which are used to treat against those hormones are the one which are derived from this estrogen and progesterone. So synthetic estrogen and progesterone which are used for the birth control pills is what you call it as anti-fertility drugs. So two examples you all can remember: norethindrone and novestrol. Norethindrone and novestrol. Novestrol is just a name of ethinyl estradiol. Ethinyl estradiol is what you call it as novestrol. So remember these two names, norethindrone and novestrol, which are anti-fertility drugs. So guys, that was all about the classification of the drugs and its therapeutic action. I'm again telling you guys will have to write down the names at least 4 to 5 times of each category and try to remember them, because most of the question you will see always coming up from the names of drugs itself. So let me summarize what we have seen so far. Right in the beginning, we discussed about what are called as drugs and how do we classify them. The second subtopic we saw how drugs interact with the molecular targets such as enzymes and receptor. And the third, which we saw, a classification of drug. The important type is this, the classification of drug and its therapeutic action, in which we included several types of drugs such as antacid, antihistamine. Then we also studied tranquilizer, analgesics. We also discussed about antibiotic, antiseptic, disinfectant, and anti-fertility drugs. Now the last part of the chapter is chemicals in food. Well, hold on everyone. Alright guys, chemicals in food. Why we have to learn chemicals in food? Because we have seen that these days we are so used to eat stored food, right? In our busy life, you have seen that in many of the cases when both husband and wife are working, they don't really get time to prepare food, so they opt for a substitute food which is basically a stored food. So the stored food and the fresh food, of course, has a difference in its nutritional value. However, to keep the nutritional value intact, we further use some of the process which is called as food preservation techniques or food preservation process. So when you talk about increasing the shelf life of that particular food, that shelf life of a food can be increased by addition of some of the chemical substances. So one of the reasons why we have to add chemicals in the food, of course, the chemicals that are added to food are for their preservation, like I said, or enhancing their appeal, that is how exactly they look like, or how exactly the color has to be used for that particular food, or they are also used for adding the nutritional value. So guys, how do we maintain this, that is preservation or enhancing the appeal or addition of nutrition value? Or we can do that by adding food colors or flavors or the sweeteners. We do it by adding emulsifiers, we add some stabilizing agents, we add some antioxidant which basically stop the oxidative spoilage of food, right? That is what you call it as antioxidant. We also use some nutritional supplements. So basically these all are the main categories which we add to a particular food in order to achieve these things. However, as far as our syllabus is concerned, we are only going to discuss about artificial sweetening agent and food preservations. So guys, let's talk about artificial sweetener. Well, when we talk about artificial sweetener, we have seen commonly diabetic people eating this kind of artificial sweetener. Also, we have seen some of the health conscious people also, as an alternative to sugar, eat this artificial sweetener. So what exactly this artificial sweetener do? Look, when we talk about a natural sugar such as cane sugar, we know that cane sugar, that is sucrose, is basically a disaccharide of glucose and fructose. So when you eat it, other than giving us a sweet taste, it also adds up to some calories. And that's why you must have seen that the health conscious people, or to lose weight, people stop eating sugar, because eating sugar also adds some calories. Hence, alternatively, what we do is we eat those kind of substances which will give that sweetness which a natural sugar gives, but won't add up to the calories. Now, why won't it add up to the calories? Is because this kind of artificial sweetening agents are never absorbed or consumed in the body. So when you eat it, they will give you that sweetness, but because they are never digested in the body, our kidney has to secrete it. So artificial sweeteners will add up to the will give the sweet taste, but it won't add up to any calories. So the several type of example which we study in the artificial sweetener, which are very commonly used by the diabetic people, one of which is saccharin. I'm sure everyone is aware of this. Saccharin is nothing but orthosulfobenzimide. Here is the structure you can see. You can remember this structure, it's pretty simple. Now this saccharin is found to be about 550 times sweeter than that of cane sugar. And like I said, since it is never digested in the body, it has to be excreted from body through urine. And it does not add any calorie to our body, because of course it is never absorbed or digested. So that was all about saccharin, very commonly used artificial sweetening agent. Just like that, we study three more. Second one is called as aspartame. Aspartame is about 100 times as sweet as cane sugar. You can see the structure right here. You are not expected to remember the structure, but yes, this is how it looks like. It is basically methyl ester of dipeptide formed from aspartic acid and phenylalanine. So you'll see there are two parts here. This first part in the structure basically corresponding to aspartic acid, that is acetic alpha amino acid, and there is another alpha amino acid that is called as phenylalanine, and this is the ester of those alpha amino acids. So it is a methyl ester of dipeptide formed from aspartic acid and phenylalanine. And where do we use it commonly? It is used in cold foods and the soft drinks. And why so? Remember, this is important data, because aspartame is unstable at cooking temperature. Because aspartame is unstable at the cooking temperature, we use it only in those foods which are preserved at a lower temperature. Alright, so saccharin 550 times sweeter, aspartame 100 times sweeter. Next is allitame. Allitame, you can see structure here just for the information, and it is 2000 times as sweet as cane sugar, and it is found to be even more stable than the aspartame. The fourth one is sucralose. Well guys, if you just check some of those supplementary food, you will find to increase the shelf life of the supplementary food, such as let's say protein supplement. If you ever see the protein supplement, read its ingredient, you will find the sugar that they use in protein supplement is generally sucralose, because natural sugar has a very lesser shelf life. To increase the shelf life of that product, we use a sugar that is called as sucralose, and this is how the sucralose looks like. This sucralose is nothing but trichloro derivative of sucrose itself, and it is about 600 times as sweet as cane sugar, and this can be used at a cooking temperature as well, because it is stable at cooking temperature. So remember, aspartame is unstable at the cooking temperature, whereas sucralose is stable at the cooking temperature. You may have question on this particular data. So that was all about artificial sweetening agent. And like we said, other than this artificial sweetening agent, we also talk about artificial food preservatives. Now, why do we need artificial food preservative? Is basically because, like we said, these days we are dependent on lot upon the food which is readily available to us, and that's why we need some of the techniques or the processes which can help to preserve the food for a very long time. So everyone, if you just talk about all the the traditional methods that we used to use in old days, like you can say addition of a salt to the food, or removal of heat from the food, or simply preserving the food in the fridge. These all are the processes, are the old age methods which used to help us to preserve food for a very long period of time. However, these days there are some of the chemical substances which are also used for preservation of food for a very long time, and one such example is sodium benzoate. So remember this name, sodium benzoate is very commonly used food preservative. Guys, after this, the last part that we'll have to learn is about the cleansing the cleansing agent. So there are two types of cleansing agent that we learn. One is soap and other is synthetic detergents. All right, let us understand first what is soap. Well, guys, let's see one general reaction here. Suppose if I say I have glycerol. Okay, so let's say we have glycerol. Glycerol is propane 1,2,3-triol. Okay, and let's say if I treat this with some long chain fatty acids such as oleic acid, linoleic acid, stearic acid, palmitic acid, anything. Okay, let's say I'm taking stearic acid. C17H35. Okay, so you can see here, this is alcoholic function group, this is carboxylic acid. When carboxylic acid and alcohol are treated, they undergo condensation reaction to produce an ester, right? So if I remove OH from acid and H from alcohol, we are going to get ester function group. Since I've got three such alcoholic OH group, let's say I'm taking three equivalents of this stearic acid. So this is second equivalent. And here is the third. Okay, and if we condense it, let's say the product that we are getting is CH2O C double bond O C17H35. CHO C double bond O C17H35. Again here C17H35, and of course 3 equivalent of water molecule. Now see the product which is obtained here contain 3 ester group, 1, 2 and 3. So I'll call this as triester of glycerol and fatty acid. Triester of glycerol and fatty acid. Fatty acid is your stearic acid. So this is called as triester of glycerol and stearic acid. Now this triester is sometimes also referred as triglyceride. Triglycerides. All right. Now let us say this triglyceride we have taken over here. Now this triglyceride could be oil or could be a fat depending upon the nature of hydrocarbon part present here. So let's say if this carbon chain or the hydrocarbon part is having some unsaturation, having double bond, let's say, then I will say this is the triester of glycerol with unsaturated fatty acids. If there is unsaturation present here, imagine, then I would say this is a triester of glycerol with unsaturated fatty acid. That triester of glycerol with unsaturated fatty acid is what you call it as oil, and like here it is a saturated one, so I will say this is triester of glycerol and saturated fatty acid, which you call it as fat. So this triglyceride is basically a fat. If I take this fat here, I'm taking that fat, CH O C double bond O, C17H35, further connected to CH2 O C double bond O, C17H35. Okay, so this is what a fat, which is basically triester of glycerol with stearic acid. Suppose if I allow this to the process of alkaline hydrolysis, if we subject this to the process of hydrolysis, hydrolysis is breakage using water. So let's say breakage using water. If we carry out hydrolysis, so everywhere ester linkage will be broken. Here as well. You'll see the left hand side part is forming CH2OH, CHOH and CH2H, meaning we'll be getting glycerol back. And the right hand side part is forming C17H35 COOH, that is stearic acid. So since we have got triester, let's say if I multiply here by 3, so I'll be getting 3 equivalent of C17H35 COOH, which is a stearic acid. But as soon as this acid will be formed, because conditions being alkaline, this base will react with an acid to form a salt. That salt would be OH will take away H plus from here. So you will get C17H35 CO O minus Na plus, meaning it is going to be a sodium salt of stearic acid. We can call it as sodium stearate. Let us write down the structure first. We have got glycerol. And along with that, we got C17H35 COONA. 3. Now this is what we are calling it as sodium salt of stearic acid, meaning sodium stearate. And dear student, this sodium stearate is nothing but a soap. So a sodium salt of long chain fatty acid is what we call it as soap, and the process of obtaining soap by the alkaline hydrolysis of fats is what you call it as saponification. So this process is known as saponification, and the sodium or potassium salt of fatty acid is what you call it as soap. So this soap is very commonly used as a cleansing agent. As we know, in our daily life we come across soaps. However, there are limitations to the soap. Well, in the chapters such as hydrogen, I'm sure you guys have come across something called as soft water and hard water. So if your water is hard, generally soap does not function that effectively in hard water, because most of the soap gets consumed by the metal ions present in that hard water. And that's why the limitation of soap is that it is not that commonly effective in hard water. So alternatively, what we do is we use a synthetic detergent. So what are synthetic detergents? Synthetic detergents are the cleansing agents which have all the properties of soap but do not contain any soap in it. Do not contain any soap, but it has all the properties of soap. And the advantage is that synthetic detergent can be used in both soft and hard water. We classify this detergent into three categories: cationic, anionic, and non-ionic detergent. Well, how exactly detergent functions to take away the fats from the fabric or from any other substance is what you have already studied in the chapter of surface chemistry. So we are not going to study the detailed ionic micelle formation of the detergent which are useful for the removal of fats or any other dust or any other substance which is attached to the fabric. You all have studied that in surface chemistry. We will be just getting introduced to three types of detergents: anionic, cationic, and non-ionic detergent. Well, this anionic detergent basically are salt of, or you can say metal salt of, sulfates of some of the compounds. Like if I have got lauryl alcohol basically you can see here altogether 12 carbon straight chain containing functional group as an alcohol. If you allow this to react with sulfuric acid, well, to understand, let's write it this way. This is sulfuric acid, and now if I remove water from here, see what are we going to get? CH3, CH2 10 times, CH2, OSO3H, right? OSO3H. This is what you call it as hydrogen sulfate of lauryl alcohol. So you can call it as lauryl hydrogen sulfate. Now here at the end, we have got sulfonic acid as a group. If I treat this with aqueous NaOH, NaOH being base, it will accept H plus ion to form a conjugate base, that is OSO3 minus, which will be balanced by this Na plus. So we are going to get sodium salt of lauryl hydrogen sulfate. So you call it as sodium lauryl sulfate. Now since the end of this compound is anionic, through this anionic end it can bind to that dirt or dust which is supposed to be removed from the fabric. And that's why such kind of detergents which are helpful for the removal of dirt through its anionic end, we call them as anionic detergent. One more example of anionic detergent you can see here: dodecyl benzene, which is sulfonated first to give you dodecyl benzene sulfonic acid. Again, when you treat that with the base will accept H plus and convert that into a sodium salt. So sodium dodecyl benzene sulfonate is another example of anionic detergent. Guys, you will just have to remember the names, and once you remember the name, I guess remember the structure is not really that difficult. So these two examples belong to category of anionic detergent. Likewise, there exists cationic detergent. A very famous example of that is cetyl trimethyl ammonium bromide. Well, you will find in general cationic detergents are basically ammonium salt of acetate or halides. But the common example which you all will have to remember is this: cetyl trimethyl ammonium bromide. So you can see there is a long chain of hydrocarbon which is further connected to nitrogen, which is methylated. So this is your cetyl trimethyl ammonium bromide. And you will see that this cationic detergents are very commonly used in air conditioners. And when you talk about anionic detergents, these anionic detergents are very commonly used in toothpaste. So as a usage, you may have some question related to that. So these two are the example of anionic detergents. And what we saw here, cetyl trimethyl ammonium bromide, is example of cationic detergents. What are cationic detergents? They are generally quaternary ammonium salts of amine with acetate or in general halides as anion. And then there exists third category that is called as non-ionic detergents. So non-ionic detergents, example that you all will have to remember is basically it is an ester of stearic acid and polyethylene glycol. So just now we saw example of stearic acid, that is C17H35COH, which we are treating with polyethylene glycol. Now if we carry out condensation, you will see stearic acid will be forming an ester linkage here. So COO and further chain. COO and further chain. So this is basically a substance which is neither carrying cationic nor an anionic end here. So you call it as non-ionic detergent. Example is ester of stearic acid and polyethylene glycol. Alright everyone. Well guys, like I said earlier, this chapter is more of information. You'll see in this chapter what all we discussed. In the beginning, we got introduced to what is called as drug, classification of drug. Then we saw drug target interaction, followed by different classes of the drugs and its therapeutic action. Then we also studied chemicals in food, where we consider artificial sweetening agent. We also saw sodium benzoate as an example of food preservative. And then the third one we talked about is the cleansing agent. In cleansing agent, we studied soaps and the synthetic detergents, which are of three types: cationic, anionic, and non-ionic. Guys, one last time, let me tell you, you all will have to write down all those examples which you studied under different classes of drugs. You will have to remember the names, because you will have straightforward question related to the name of a drug and the class it belongs to. You need to know if particular drug name is given, then it belongs to which category, whether it is antihistamine, whether it is antacid, whether it is analgesic, whether narcotic or non-narcotic analgesics. Any of that sort of question will come, but it is going to be related straight away to the name of drug. So guys, that is it from our today's chapter, that is chemistry in everyday life, an informative chapter. I want you guys to practice a lot about writing the names. Again telling you, write down every category drugs at least 5 to 6 times so that you will be able to remember it for a long time. So that is it from the chapter of chemistry in everyday life, the last chapter of organic chemistry, and we announced that the organic chemistry syllabus has been done here. Thank you so much everyone. I'll see you soon in the next course next time. Until then, bye bye, take care.